last class we have seen that, so especially power and energy management, we need a specific strategy. So unless otherwise, even though the vehicle is designed properly and all the components are we are properly sized and we have allocated the space and maximize the space available for traveling and minimize the load and etc. So all the things we have designed. But unless otherwise, we have incorporated certain strategy for power and energy management, especially in a hybrid electrical vehicle. It is a technology. So unless otherwise we follow the technology, a proper technology, we cannot come out with a vehicle performance is a acceptable one. So vehicle performance is acceptable one means, so we are going for hybrid electrical vehicle configuration in order to have a very good fuel economy. If the hybridization is less, percentage is less, say for example, 20 30 percentage only I am going for hybridization means that the main aim is we are going for the fuel economy. Fuel economy. Suppose if you go for more hybridization, so especially in case of a plug-in hybrid electrical vehicle and all, so there also we are going to use, suppose 70 80 percentage hybridization means remaining 20 percentage of power, propulsion power has to be produced by the internal combustion engine. There we have to properly utilize. So when that particular IC engine has to be engaged, at what speed range or what power required range. So these are all the things very importantly we have to go ahead. So for that we cannot, driver cannot have any control over that, because even though the assume that the vehicle when the normally running, so driver is capable of controlling the direction and speed and etc only. So in turn he is also giving the input command and signals only in terms of pressing the pedal and proper pedal, brake pedal or accelerator pedal, whatever it may be. So that has to be taken care. And in addition to that, all the other parameters, especially vehicle speed, at what terrain it is moving, and how much is the state of charge of battery now, so that, and accordingly how we can engage. So what is the way, so after certain kilometer of range, how this hybridization has to be behave. So because once hybrid electrical vehicle means, it doesn't means that from the standstill to whatever the full speed or maximum speed it is going, all the time I have to engage both the power propulsion system. It doesn't mean that. So I can decide accordingly. So it initially it may be starting as an electrical vehicle. Then later after certain speed or it is capable of running certain speed, I can able to convert that as a IC engine only. So purely propulsion power will be produced by IC engine. So the portion of the propulsion power may be used for generating electricity, which in turn may be charging the battery. Okay, so after certain speed, exceeding the speed or exceeding the power requirement, then once again electrical motor may be coming to the picture, so that it can contribute, that it is a sliding mode. So whenever increasing from that power, it is increasing, the additional power required will be provided by the electrical motor. Likewise, electrical motor once it reach the maximum level, so then we can further increasing the demand, increased power demand from the internal combustion engine. This is how it is properly designed in case of a mild hybrid electrical vehicle. So based on the configuration, whether it is mild or plug-in or more or powerful, so hybridization. So this the energy hybridization more amount of power. So based on that, definitely my strategy will be changed. So who is going to control? So already we know that in ESS, energy storage system, it is not only it is the source where we are going to get energy. In addition to that, it is EMS also. Energy management system is also is there. That is nothing but a controller. So that controller may be a combinations of some hardware component or some hardware components along with the software also. So that is what here now in all modern electrical vehicle we could see that in energy management system it is a combination. It is a combination of hardware and software. So for that, as I already told yesterday, explained, that is every behavior, every second behavior of electrical vehicle, expected behavior of electrical vehicle cannot be mathematically modeled. If it is so, then it will be very, very tedious process. Then we have to identify all the methods and we have to go for sometimes iteration, sometimes approximation, so many problems in there. So solving the problem of these things, how to engage, how to facilitate the power flow so to the vehicle. So from which system, electrical system or combination or only the IC engine, when it has to be engaged, when it has to be cut out. So all these things has to be done. So that cannot be mathematically modeled, or it can be modeled, but it will be a very, very complex system. So you need, or you make the entire system as a slow down. Okay, so because as the vehicle movement is concerned, so every second it has to be always monitored. Accordingly, the decision has to be taken. Okay, so even a even a second or even a few seconds delay make the particular system is ineffective. So that is the reason why we are going for the smart computing techniques, especially soft computing techniques. Soft computing techniques, especially the fuzzy logic. Fuzzy logic is a very good solution. So it is capable of always we can able to monitor the system parameters lively. Accordingly, what sort of decision has to be taken. Suppose if we have a certain rules, okay, certain number of rules that can be specified. So based on the specification, based on the input, we can able to decide. So what sort of decision has to be taken. So especially the fuzzy logic controller is a very good controller, especially the logic control, fuzzy logic controller. So automatically, so nowadays the modern electrical vehicle and all implementing that. So there are other smart computing techniques also is available. So one is a genetic algorithm, and another one is a neural network. Another one is a particle swarm optimization and colony algorithm. These are all exactly it is imitation. It is imitation of a living being. Say for example, if it is a genetic algorithm, how uh, living beings are evolution of living beings. So how to parents children their chromosome, so because of that how good the children. So this is a genetic engineering. So based on that, we are generating a solution also for a particular problem. We are generating a good solution based on imitating the particular genetic engineering concept in engineering problem, that is called genetic algorithm. But likewise, ant colony algorithm. What is the nature of ant? Wherever it may be, suppose if it is capable of smelling, so or within the range of smelling the any sugar and all, it can able to present within a few less time. So it can able to present in the particular place, and it is start carrying the particular sugar or whatever the edibles available to their nest. So there is we can't able to smell that, but it is capable of making a path, a shortest path to that particular edibles, and it is capable of taking that. Okay, so even though no other living beings are capable of notice that, that is having a very good sensitive. Okay, so this behavior. Okay, this behavior we are taking to the solving the engineering problem. So we are approaching the engineering solution very short path. Okay, and continuously. So this is how we are imitating all the behavior of living being. That is a smart computing technique. So no ant or no bird, if they are searching for their prey and etc., they are not following or they are not framing any mathematical problem and all. So they are using some other sense the same way, without mathematical modeling, without the physical modeling. So actually, out of all the modeling, physical modeling, okay, all the modeling types, mathematical modeling is seems to be giving a very good solution. So with the assumption that the parameters interested only, I am very much interested. So all other influencing influencing parameters, if it is negligible, I can able to make it negligible. But whereas there is a better solution available, that is nothing but imitating the behavior of living being, like these things, genetic algorithm, uh, particle swarm optimization, ant colony algorithm. So the a lot of gray wolf type of algorithm. So how they are all hunting their prey, and that is food. Okay, how they are behaving naturally, so to find any edible foods and all. So the same concept. Okay, same way we are going. So likewise, in neural network. Okay, neural network is how we are behaving as a human. Okay, so we are all having in a brain all the neurons. Suppose we are sensible to the particular one. So certain amount of neurons has to be energized and engaged. Okay, so then only we can able to sense that and we can able to accordingly behave. So that sort of behavior and concepts were implemented in smart computing techniques. So one such a smart computing technique is fuzzy logic control. So mainly in electrical vehicle, whenever you're going for electrical vehicle, particularly in hybrid electrical vehicle configurations, so the particular fuzzy logic controllers is helping a lot, because all other thing it needs some iteration, it is undergo some iteration, it's undergo some process, and also so out of this, the fuzzy logic is found as a very effective one. So very importantly, if you want to design any system that is with managing the power and energy, because already we know that power and energy once again syncing in the same. So power is nothing but an instantaneous one, instantaneously how much power. So energy is nothing but integrated power. So from particular specific period, so for particular specific period, how much power that is spent. So that is nothing but energy. So integrated power consumption is energy. So in this case, we can able to identify certain rules, because when we are going for a fuzzy logic controller, it's a rule-based system. It is a completely rule-based system. So fuzzy rules, we have to decide the fuzzy rules. If certain things are there, if certain things are there, what is then? If then rules. We usually in fuzzy logic operation, the fuzzy rules are if then. If the speed is like this, if the state of charge of battery is like this, then what should we do? Whether we have to engage the motor or whether we have to engage. So I am saying example. Suppose I have to decide. Okay, so from 40 kilowatt to 40 to 70 kilowatt. As per the rule, 40 to 70 kilowatt, as per the slide showing here, I have to engage both the thing. But whereas IC engine is engaged with the full capacity of 40 kilowatt fixed. Okay, full capacity in the sense fixed. It's not a full capacity, it's a fixed. But whereas electric motor is can be slide. Suppose when the exactly 40 kilowatt IC alone is engaging, 41 kilowatt means electric motor will start delivering 1 kilowatt power. So 45 means 5 kilowatt power will be delivered by the electric motor. So likewise, it is going up to 70 kilowatt. But in this situation, so if you want to really do, suppose what I have to do if the required power is 45 kilowatt, okay, and electrical motor power required is 5 kilowatt, and state of charge of battery is less than 30 percentage. In that situation, what will happen? If I am engaging the electrical motor, as per this rule, it is not acceptable. So I have to keep on engaging internal combustion engine only. But whereas the motor power can be limited to, instead of 0 to 30, I can able to limit it to 0 to 10 kilowatt, because the state of charge of the battery is very less. Okay, nearer to completely depleting. So nearer to the complete discharge. So it is about to discharge. Suppose 30 percentage means. So in that case, I have to select the appropriate tool. So likewise, for a complete management system of power and energy management, we have to frame number of rules. Number of rules. That is what here it is given. That is what here it is given. So it is a very big number of rules are available. So especially for when we are going for a practical application, when you are going for really for a practical application, for demonstrating the behavior and demonstrating the effectiveness of any logic fuzzy logic controller, we can able to explain the effectiveness by using this number of rules alone, 6 7 8 some 10 rules or 6 rules, okay, with having some subdivisions and all, we can able to explain. But in a practical manner, when we going for practically implementing, okay, there we need not to show the effectiveness, because effectiveness is already proven. So how what are all the possible rules, all possible rules that we have to take into consideration. After that, we have to make it as a falsifications. That is, we have to make it as a table. Okay, so uh, it's a rule-based system. So automatically we have to table. So if then rules, if this and this and all behave, if these are all the, suppose if I am taking the three parameters. like the example shown here or the black diagram shown here. I am taking only, I am interested in three parameters only. Based on that, I want a decision. So for the final decision, I want to know only the engine speed at present. In addition to that, what is the optimal operating power of the engine? Okay, so but mainly it is decided by three parameter because my fuzzy system is only considering these three. It can be of any number of parameters, even one only state of charge of battery we can take, only vehicle speed it can take. So for a realistic, for a real time problem, I have taken here three different parameters. So one is velocity, okay, vehicle speed, at which speed it is going, and what is the present battery charge, state of charge. So this is, so if you see that all these are going to be varying, so vary time to time. Okay, it may be varying. It is not a fixed one. It is in a dynamic one. It is showing a dynamic behavior. So because so vehicle speed, it is completely under the control of driver. So the driver has to decide. So what is the pedal position of acceleration? Accelerating pedal position based on the vehicle has to be produce a certain speed. Then how much so far it is consumed from the battery based on the state of charge is going to be. Okay, so initially when you are assuming that it is an lead acid battery pack, so I am assuming. So from the battery point of view, not at operating voltage point of view, the battery point of view, if it is a battery pack voltage is 12.8 voltages, after 50 percentage of the uh, energy capacity of the battery is used, definitely the state of charge of the battery will now fall down to 12.3 or 12.2 voltage. 12.3, assume that 12.8. So zero point 0.5 voltage may be different. It shows that so already a 50 percentage of the energy is consumed. Okay, so vehicle power. So with these two are in turn, it is connected. So how much the vehicle speed required, the driver is deciding. So he based on the vehicle power has to be generated. Total power has to be generated. So as far as the hybrid electrical vehicle configuration is concerned, here it is purely depends on how much is the hybridization rule. So here the rule is coming. If these two are here, these two are interconnected. These two are interconnected. So automatically here, if these two are interconnected, then automatically this is also related because now I have to engage. Okay, now I have to engage my motor also means automatically that engaging the motor, how much we can engage the motor depends on the state of charge. So even though these are all three parameters, each and everything is interconnected because of the present position of that, each will be altered. Each will be going to be altered. So how much we have to alter? So what is the optimum point or what is the uh, purpose we have to do is we have to maximize the fuel economy and we have to maximize the efficiency of the system and we have to minimize the cost involved. Okay, so automatically, so here that is what we are. So I have to design n number of rules. These fuzzy rules, no. So for example, only we have taken. So in the previous case, for example, only some six rules we have taken with subdivision and all. So suppose if it is the range and etc. But in actual practice, it is having n number of more 50, 60, 70 rules will be there. Okay, so every whenever these inputs are given, okay, whenever these inputs are given automatically, okay, so that will be falsification because this will be analogous. First it will be converted to digital, then falsifications value. So it will be converted to a for fuzzy logic controlling falsifications. So it will be converted into whether it is very grade speed, very less speed, normal speed. Likewise, the falsification will be done. Falsification is in this sense, it is not doing any mathematical model. So what is the state of charge now? Suppose assume that I am only taking the considering the state of charge of the battery. So now the battery state of charge is 30 percentage. Okay, 30 percent at this second, at this moment. Assume that. Okay, so then it will be pacified. So this is what? Very small state of charge, very small, very small. Suppose if it is 40 percentage means it will take it as a small, and 70 percentage means little high, and if it is 90 percentage means very high. So the entire charge range from 0 to, actually it will not 0 to, for the sake of understanding, 90 percentage, okay, 9 percentage, okay, I can able to divide into so many ways of understanding. So here only how the digital logic concept and it is varying, because as per the digital logic concept, whatever may be the state, I can able to say either low, that is 0, or high, 1, either low or high. I cannot say it is very low. So 0 only low. Next state is high. So digital logic system. Why I cannot employ digital logic system? I am going for fuzzy logic system. Means in digital logic, it is having advantage that either low or high only I can able to understand by means of zeros and ones. But here in fuzzy logic, even though 0 to 9, I can able to divide into number of sections. Okay, very small. So I can say suppose 10 percentage means ultra small, ultra small. So I can able to specify the state at which. So what is it is taking? If I have to rule, if state of charge is ultra small, so even though the required power, vehicle required power is between 40 to 70 kilowatt continuously, then engage only internal combustion engine. Likewise, I can be able to decide the rule. So because every segment of the percentage of the battery here it's considered. Whereas digital logic circuits, I don't have any provisions like that, because it can only able to whatever may be the system parameter, it can able only able to understand as a two states. Okay, so normally we are speaking it as a on and off, or in logically we are speaking it as a low and high. Normally we are speaking it as a on and off. On and off means on means one, off means zero. So logically low and high only. But here in between this low and high, ultra low, this may be where we can say that low, ultra low, very much low. Okay, normal, large, very high. Likewise, I can have, so even 10 percentage I can able to categorize. So I can able to use fuzzy rules. Okay, it is like a practical way. So this cannot be mathematically modeled. So I am dividing the entire percentage of range of state of charge as so many divisions I can able to possible. For all these so many divisions, I can write the rules. Fuzzy rule. If state of charge of battery is very high, so up to what level I can able to allow the normal operation in this region, normal operation in this region. So even though I have decided like this, if a state of charge of battery is not supporting, I can eliminate, I can introduce a rule, okay, overrule the previous one. I can introduce a rule which overruled the previous one, so which is very specific because of the data charge is low. So likewise, I can able to write n number of rules. So the table, fuzzy table can be created. So automatically after the specification, so this fuzzy reasoning will fire. Okay, based on the three parameters, I will, which will fire one rule. Okay, one rule. So one rule will be matched with all the three conditions. I am having n number of rules. Out of the n number of rules, one rule is going to be matched with the present input of the particular condition. So that rule will be fired. So that solution will be taken. Then it will be de-specified. Accordingly, I have to engage whether motor only or this much power only. Likewise, I can able to. So if then rules, if these things are there, then what do you have to do? So here it is a logic controller. Okay, but logic controller but can capable of doing n number of logics, n number of logic. Out of that particular one, it can only able to select one set of rule only may be matched.
Okay, so in a precise way I can able to control. So next second the situation may be varying. So I have to, driver may be giving a vehicle speed, he may be going for decelerating, or he may be applying braking. So decelerating, applying braking means automatically it has to come down. So vehicle power record will be zero. Then immediately from this position to it will come to here. So when the diesel from 40 kilowatt to 70 kilowatt of power requirement, when the driver apply braking or decelerate, he simply take the leg from pedal. So it is equal to decelerate. So no power required. So vehicle has to decelerate or braking means. So immediately I am coming into the 0 to minus 30 kilowatt range. So here we should understand that it is not going to be always sliding. So from any point of view, from it may be coming here, from any point of view it may be coming here, any point of view, from any type it may coming from positive side to negative side. So at that time what sort of, so next immediately that we will make one rule. If vehicle decrease, okay, so it decreasing or this much, okay, so it is completely taken, it's applying a braking means, then automatic vehicle power record zero, then what has to do? So then immediately the motor has to operate as a generator. So no power has to be produced from IC engine as well as. So this recapture, the capture of all the regenerative powers has to be fed back to source. So it should be properly stored in the battery. How it is? So the generator is acting. Generator now, suppose if I am using induction motor, it will be acting as an induction generator. So there will be reversible power flow. Accordingly, I have to set a firing angle of an alternate, that is a power electronics, power circuit, power modulator. Then it will facilitate the reversible power flow. The voltage at which it is producing I cannot able to store. So that has to be stepped down, or that has to be produced in the DC voltage. Accordingly it can capable of charging battery. So suppose 12.8 voltage means I have to produce 15 voltage, 15 voltage with a large amount of current, with a large amount of current. Okay, so this is how, suppose 90 amperes. So this is going to be happen for fraction of second only, fraction of second only. So next moment, the driver may be giving a vehicle speed. Instead of decelerating, now he may be accelerating. So vehicle power required. So now once again from this position to, so it is going to be transferred to 0 to 8 kilowatt. Then after certain second, 8 kilowatt to 40 kilowatt. After certain second, it will keep on going. It will be keep on going. So this can be controlled. Okay, this can be not only controlled, here the power and energy can be managed properly if we are any one of, is among that, which is very first is rule based, that is nothing but fuzzy logic system only, it is mainly suitable. Next one is we can have implementing a genetic algorithm. So which having a genetic algorithm. So we are going to discuss, okay, that also. Uh, do you have any clarification? So suppose this is a situation. This is may occur at as a one instant. Okay, so one instant. Suppose assume that an hybrid electrical vehicle is there. It is having a battery SOC specifically 56 percentage. Okay, so up to minimum 40 percentage only it can discharge. So it is a condition. Minimum of SOC is 40 percentage. Maximum SOC is 60 percentage. Okay. Vehicle speed now it is given as 30 kilometer per hour. Vehicle demand power is 25 kilowatt. So based on this three input, I have to determine the required power from electrical motor. Out of this 25 kilowatt required, how much power has to be going to be produced by electrical motor, and how much is going to be contributed by the internal combustion engine. That I have to decide by fuzzy rules. So automatically, if you are mathematically formulating, you have to incorporate so many equations, lengthy equations. Finally, only we'll get. But instead of that, if I've set rules, already rules are there. So appropriate rules will be fired. Appropriate rules will be suitable will be selected. That will be fired. for that defalsification will occur. That defalsification will give the result. Okay, so we are going to see in subsequent classes. So I'm going to explain with this problem. So as far as this unit is concerned, because it will take a minimum 2 hours. So because first we have to make all falsifications. Okay, falsifications of the parameters, then fuzzy rules has to be decided, then we have to go for fuzzy reasoning, then we have to go for defalsifications. Okay, after that only you can go. So it definitely to understand the problem you need 2 hours, but of course in examination within half an hour or 35 minutes 40 minutes you can able to solve it. So that will be usually will not be in examination. Okay, because it is a high level cognitive level of the solving this problem required is very high level, because it is not only in the apply level. Okay, not in the analysis level. It is a create. You have to create a fuzzy logic system. Okay, so which is capable of handling this situation, this input also. So the cognitive level is very high. So if any cognitive level more than BTL level, Bloom's taxonomy level, more than 4 means we cannot able to assess the in examination. But as an engineering student, you should know these things, even though it may not be. It may be asked in assignment. I'm going to, yeah, I forgot one thing. I'm going to give you an assignment. So, as far as the structure of internal assessment is concerned, so not only the continuous assessment test alone is going to be, you have to submit the assignments to it that you know already. I already said. Okay, so I will forward the questions to you. All of you are asked. All are asked to submit the particular assignments in the Google Classroom. Okay. So in the Google Classroom, announcement will be coming. So why still many are not at joined in Google Classroom? May know. First, we want to know whether having any clarification up to this. Any clarification in the power and energy management of electrical vehicles. Is there any clarification? No. Okay. So why many are not at joined in Google Classroom? Hello. Okay, anyhow, I'm going to assess based on that only, because already for the CAT 1, only 22 people returned. CAT 2, only 25 returned, 3 were absent. Okay, and this assignment also I'm going to assess, because there is no any provision for getting that assignment and corrected it and return back. So that is the purpose why I have created the Google Classroom in order to collect the assignments. Okay, so area I already the link is posted even in the WhatsApp group also. All the 28s are not joined. This is a very very bad thing. So finally you are going to the lose. You are going to the loser. Okay, so because if your name and if your content, if your assignment is not reached means automatically I cannot give any marks. Okay, so it is very very easy. Okay, as far as the, because we are unlike Anna University and other university, they have allotted only 20 percentage mark for internal. Remaining 80 percentage they are assessing through the end semester examination. But you are fortunate. Okay, we are giving 40 percentage internal mark. Okay, just like that you can score. So because it's nearly going to be decided examination. Apart from that, assignment and other activities also is there. Okay, based on that only, plus attendance also, five marks is there. Okay, so 40 marks you are getting. So but out of that, total 150 mark is passed. So one must be getting. So engineering student in our university should get 35 and above. 35 minimum should get. Okay, out of 40. Okay, that should be, you should earn that mark. So automatically in the final examination will not be much burden. Very easily you can get a class with the distinction like that. Okay, but people are still, you go and see in university students where 20 percentage only is giving us internal mark. Okay, they are struggling, they are studying more.
Okay, but you have to study more and you have to secure more marks. So, okay. So next we are going to see as a second part of the particular unit. We are going to see the comparison of the vehicles. So now we are coming to almost coming to the end of the syllabus. Now the complete part is going to be you have to compare the different electrical variants of it. So whether it is starting from an electrical cycle to up to a latest Nissan Leaf or Tesla model car and etc. So to compare that, first you should know or you should have some idea about particular cars, okay, particular vehicles and all. So for that only I am presenting. Of course, I just leave it to a part of comparison to you because I am going to give you completely the basic and history and other specifications of particular type of electrical vehicle. I'm going to give it to you. So I'm going to leave the part of comparison to you. Suppose if I want to ask you to compare the electric cycle, okay, electric cycle that is with the low speed rechargeable battery vehicles. So in that, what are all the vehicles will be coming? Okay, so you can able to compare that. First part we are going to see. So what are all the low speed rechargeable battery vehicles? So even though the battery vehicles can be many battery vehicles are there. Okay, so it is having a category. It is also having a categories also different categories are also is there. That is mainly okay electric bicycle, low speed vehicles. Okay, so especially still that type of a low speed vehicle concept is existing in USA and Canada. So what is a low speed vehicle? It means maximum speed of 40 kilometer per hour. That is nothing but 25 miles per hour. Okay, so you know 1.6 kilometer, 1.6 kilometers equal to 25 miles per hour. So and thirdly, the conventional road vehicles that is using the rechargeable batteries. So in addition to that, there are special purpose delivery vehicles also is there, such as forklift trucks. Okay, so and we have seen that and a small four-wheeled carriages. Okay, in addition to that, even electrical vehicle is not having any limitations. So only the category only is this that it is keep on expanding. So even I can say that ships, cargo ships and cruise ships, and also that is now it's propelled by means of electric propulsion is there. So there also a hybrid concept only is used because it's completely and there is no any complete electric type of cargo and cruise ships are there, but a small ships, okay, shipping industry, then now they started adopting these things because so they can able to produce. So especially pollution, completely pollution free. As I already told, compared to the internal combustion engine and all, less space only is required. So whenever you are going for that, because so if you see the propulsion, okay, propulsion, so that is nothing but under ship, there is a need of propel. Okay, that has to be continued rotating a very high speed, and the direction can be changed. So a lot of azimuth pod drive, lot of drive concepts are already coming. Okay, so because of that, it need not to be propulsion power need not to be created by so internal combustion engine alone. It can be produced by the electrical motors also. So now as a implementation part, some of the ships they already started as a hybrid. Okay, so they are incorporated some of the small rating power. So as you know that cargo ship means whatever uh, power rating from 10 megawatt to okay 100 megawatt. Usually it is required. So suppose it's a small cargo ship means 10 megawatt, maximum 100. So likewise cruise ship, why they are going for this type of electrical power propulsion is so they have to produce the electricity for cruise ship means we are having some luxury hotels, lot of lighting and other things will be there, swimming pools, okay, and other heaters and other arrangements also required in the ship. So the huge amount of electricity they have to produce. So instead of that, they're completely going for electrical propulsion also. So the total power out of the total power generation, some 60-70 percentage will be exclusively used for this type of propulsion
and 40 percentage used for this type of electrical loading, lighting and other cooking loading and all, because we know that now it is electrical energy is applicable to all type. Okay, so even in cooking, induction concept, induction principle is used. Okay, all type of thing, all type of energy, even a heat energy can be very effectively produced. So as far as this shift and all concerned, now they are switch over. As I told you earlier, okay, uh, types of electrical vehicle. Okay, so it is not limited up to four-wheeled carriages, even electric train. Okay, we have seen that traction, electric traction, that also used. So these many wide ranges of electrical vehicles are the starting from low speed rechargeable battery vehicles like electric cycle. So here, as an example, I have taken a Frigo Hawk electric cycle. Okay, it's a Hawk electric cycle. So this is what permitted, especially country like UK, United Kingdom and all. Still, they are uh, in order to ride this type of vehicle, you should have some certain age limit also is there. Speed limit is also is there. Okay, so very popular. Okay, only in India, like countries, still it is not getting popular. So foreign countries, they already they started using. Okay, especially in last 20 years. Okay, after 2000, especially after 2010, last decade, completely one decade. So the popularity of this type of low-speed rechargeable battery vehicles are coming. What is the advantages also is there? So here they are using another one concept of hybrid, that is manual pedaling. So not only it is going to be completely like a scooter, electric scooter, it is going to be. So you should understand what is the difference between electric scooter and electric cycle. So electric scooter is you need not to give you, there won't be any pedal arrangement. There won't be any pedal alignment in electric scooter. Complete propulsion will be taken care by a small electric motor, which may not be more than the rating of 250 watts. So only we have to give the acceleration. So that means speed control only we can give. So automatically how much voltage we are applying. Voltage can be varied uh, to the motor. Accordingly, I can able to control the speed. But whereas electric cycle, it is having a combination of both. It is having a motor, okay, less than the 200 watts. So yeah, sometimes it has to be pedal assist. That's what I hear mentioned. Okay, so mainly you have to understand the difference. That is mode. Here, if you see the mode, pedal assist or pedal only switchable. So it is having a both thing. So I can able to assist. Suppose I am using a motor. Okay, so initially you have to use the pedal assist. Okay, so to reach certain speed, though only the maintenance of the speed will be taken care by the thing. There also you can keep on doing the pedaling. So cycling like that. Okay, so sometimes, so pure power, when it's reach pure power, electric power is after reaching certain kilometer speed, after reaching certain speed, so only for maintaining it, the pure power can be. So initially or at slow speed, okay, there is a need of pedal assist. That is the reason why it is called electric cycle. So you should understand what's the difference between low speed chargeable battery vehicle. First comes is electric cycle. What's the difference between electric cycle and scooter? It is pedal assist. Automatically, if other things, if you see that it is a standard dimension, 26 inches, frame is 18 inches. Okay, motor is 250 watt, brushless motor. Okay, hub motor and speed control. Okay, handlebar mounted twist throttle. Like we are giving acceleration. No, that is called twist throttle handlebar. It is mounted in the handlebar. So range pedal assist mode. Okay, 15 to 20 miles. That is nothing but 24 to 30 kilometer throttle only. How much is the capacity? Is 10 ampere hour battery. Okay. So and another one ranges is 30 to 40 miles, which need a pedal assist. Okay, which need a pedal assist because up to 15 to 20 mile, 24 to 32 only with the electric power. Okay, with the throttle only I can go. So if you want to go more than that, in addition to that, you have to do pedaling. Okay, so with the same capacity battery, with the same capacity battery, you can able to assist. Okay, and of course battery is lithium.
Okay, lithium battery 10 ampere. Because what is the difference between the other battery type of 10 ampere or lithium is which can sustain for long period. Okay, so because of the energy density is more, it can sustain for a long time. Okay, so when we are discharging, okay, so and charging time, okay, so within 2 to 3 hours, it is reaching a 80 percentage of charge. For remaining charging, it will take another 2 hours. For full charge, 6 hours. Okay, so these are all the things. So this is a one thing. First kind we are seeing there, Free Go Hawk. It is a company name. It is a brand name. Free Go Hawk. In India, lot of electric vehicles and electric cycles are very less only is there. Okay, electric scooters, a lot of electric scooters are coming. Do you know any electric scooter manufacturing in Tamil Nadu? Anyone of you? Because we are all studying, as I already told, being a final year, you should, apart from the subject matters, you should aware about more things, especially when your resume carries this information. That is, you have studied or you undergone the course called Introduction to Electrical Vehicle. They will be very curious. Okay, their curiosity is knowing about electrical vehicle. What all things you know about electrical vehicle is very important. Anybody having any idea? Do you know any company, electrical vehicle, electrical scooters manufacturing in Tamil Nadu? Tamil Nadu. I am not even taking attendance. Yeah, why you are taking present? Only for attendance you are coming, ah? Hmm? Kevin Smith.
Shuttle cars is there, sir.
Eh?
Shuttle cars.
Shuttle?
Shuttle cars.
Is it manufacturing in Tamil Nadu?
Manufactured in Tamil Nadu only, sir.
Where?
I think near MSME.
Okay.
MSME, Hindi.
MSM. Okay, Chennai, ah?
Yes, sir.
Okay. Another? Any other? Another one is very important now. Nowadays, it's popular that Ampere vehicles. Ampere vehicles. They are having manufacturing plant many places, especially in Coimbatore. They are having a very good manufacturing, starting from assembling, okay, testing, quality control testing, everything they are having. Not only
Yes,
in
sir.
Coimbatore, they are having a manufacturing unit in Vijayawada also. I think Vijayawada and other Karnataka also one places. So South India. So the South India they are having 2 3 plants they are having. So major one is in Ampere vehicles in Coimbatore. Okay, so they are manufacturing. They are not manufacturing any electric cycles, small electric scooters, small electric trucks. Okay, so three wheeler. Okay, so some rickshaw like that also they manufacturing. Okay, so for truck carrying, so carrying small loads and all carriages. Okay, electric carriages like that they are manufacturing. Okay, so what is the advantage of that one is they are going, they are recently they are switched over from a lead acid, okay, and nickel metal ion battery to lithium ion. Okay, so because of the many customers they complained about the life period of battery, even though it's assured 2 3 years. So within 1 year, 1 years, the battery is completely not usable. So that means more water content is created. Okay, so the battery is getting diluted means automatically it cannot store much charge. Okay, so it is a reversible process only. So that is not possible means then they are gone for a lithium ion battery. Now they are expecting that at least even though they are assure given assurance that 5 years it will go, 5 6 years it will go. So definitely they are saying 4 years it can go without any problem even at the rough usages. Okay, it's a daily usages. Daily they going within a charge 80 kilometers 80 kilometers. So usually normally in any urban area
and suburban area, not city. City, even though there seems to be ride more, okay, so maybe 50 kilometer averagely, but in urban and suburban areas, averagely in any vehicle in a day, it may go maximum of 40 kilometers only. So if it is once they charge, okay, once they charge, it they can use the vehicle for 2 days, okay, 2 days. So with 5 rupees, 1 unit only it may be coming, or 2 units, even if it is 2 units. So per day only 5 rupees for 40 kilometer traveling. It is very economical, and that too for about 4 6 years. They are saying 4 years it's good. So it is in the hands of engineers, especially those who are studying. So whether you are doing it, okay, I hope that you with the interest only you are taken, whether forcibly or by means of with the interest. But you have to bring the changes. Okay, so because as you know that in the car show, okay, in the car show, see in the 1902, okay, there is only one internal combustion, two internal combustion engine vehicle only is there. Rest of them are all using cars. It's a cart. Okay, but immediately in 1917, when there was a show about the vehicles, so more than 50 percentage of the vehicles are from internal combustion engine. Now nobody nowhere in foreign countries they are using a horse, okay, horse rider cart and all. Completely cars only. Okay, the same way that kind of changes can be bring if people like you also started using electrical vehicle. Okay, mere studying and going alone without that we have to go. So as I already told that retrofitting technology. So being that is a very good earning capacity. So try and learn a lot of companies are there conducting okay this type of courses, especially retrofitting. So that means we cannot change the existing vehicle to electrical vehicle. Okay, very easily without having exclusive technology, how to do that and etc. That set of courses and all conducted. So if you know that, automatically we can able to convert our even the Maruti car is there 800 Maruti 800 vehicle is there. Okay, and Alto 800 is there. Very easily you can go for retrofitting of these vehicles means so nearly 40 to 50 percentage of fuel economy is there. Okay, with additional small space only is required for incorporating this type of motors and battery units. Already is having a battery capacity only. So we can able to convert this type of things as a hybrid electrical vehicle. But this type of small power, okay, so 800 engine, 800 cc engine. Okay, if you are going for hybrid vehicle, 40 to 50 percentage of fuel economy is coming. Okay, so once they charged, also it is going to be long last for 10 days. In addition to that, per liter, if a Maruti 800 car is giving okay 16, 15 kilometer to 17 kilometer means so it can capable of giving 30 kilometers. Okay, in addition to that, the battery power motor is supported. So this type of retrofitting technologies also is there. Then very importantly, the existing bike and all no that is using a petrol. How to convert that as an electric vehicle also they are using. They are giving these type of things. So you learn that, bring the changes in the society. Okay, because a small battery, we are removing the internal combustion engine and adapting the battery. Okay, that with a complete chassis arrangement and the components and all available. Now I think in India nowhere components, these type of small discrete components are required for retrofitting is available, but we have to um, import only. But the reasonable cost it is available. Only thing is that technology has to be taken place. So tomorrow onwards, we will see the rest of the type of all the cars and all we are going to see. Okay, and then finally we will compare. Okay, okay. Today I'll take attendance.